Hello friends, in this clip I want to introduce 33 kilovolt switchgears to you. In this substation, all switchgears you see are 33 kilovolt. The switchgear we have here includes two incomings and a coupling that you can see here. This is our incoming cell, incoming 1. Its voltage, as you can see, is 33 kilovolts and it is now under load. The voltage is connected and you can see its indicator that shows we actually have voltage at the cable here. So this is our incoming 1. We also have incoming 2 here. In fact, we have two 33 kilovolt incomings. We have one bus riser cell and one bus coupler cell. Inside the bus coupler cell, there is a breaker that connects bus number 1 to bus number 2. Bus riser in this cell raises the bus bar at the bottom of the breaker and connects it to the next bus. Well, before incoming 1, they are all outgoings. As you can see, all of these are labeled outgoing. Outgoing, outgoing, and so on. These are all outgoings and are related to incoming 1 and are fed from bus number 1. On the side of incoming 2 onwards, they are all outgoings as well. As you can see, from here on, they are all outgoings, fed from bus number 2. They are outgoings up to the end. This side is also outgoing. And what you see here is the bus duct that connects the buses of these two switchgears. In fact, with this bus duct, the bus bars of these two switchgears are connected to each other, and this side is also totally outgoing. As you can see, all these are labeled outgoing, and up to the end, they are outgoings. So I will explain to you the equipment mounted on one of the outgoings. Up there is located the Siemens relay, model 7SJ80. Next to it is the test box, which is related to the relay. These two that are next to each other are lockout relays. This is TCS or Trip Circuit Supervision relay. This is the discrepancy switch by which we can disconnect or connect the feeder. Now, because it's aligned with our output, the breaker is closed. This is the semaphore that is aligned with the earth path, indicating that the earth is disconnected, and when the earth is reconnected, the semaphore will be aligned with the earth disconnector. This, as I said, represents the voltage, which indicates that we have voltage at the output. You can see the local remote switch by which we can execute commands remotely or locally. We have the lamp test, which if we press, the lamps will light up. We have a reset knob that resets the lights. If the breaker is in test position, this light will be turned on. In service mode, this red light is turned on, which is also on now. CB ready will be turned on when the breaker is ready to close, which is also on at the moment. Here is where the handle is placed inside the panel, by which we can open or close the ground disconnector. This handle is for ground disconnector. Okay, here also a handle can be placed inside, by which we can put the breaker in test or connect position. They work together with this latch. When we press the latch, the handle can be inserted and the breaker might be put in test or connect positions. And this is the 33 kilovolt breaker that you can see here. Its nominal voltage is 36 kilovolts and its nominal current is 2 kiloamperes. It is manufactured by Siemens and is mounted on a trolley, and we can rack in and rack out the breaker to be mounted inside the switchgear. Here is the breaker control socket. From here, the internal control circuitry of the breaker is connected to the switchgear. Yes, here you can see the 33 kV trolley with the breaker mounted on it. Here you also see the 33 kV vacuum interrupter. The breaker is of vacuum type and its contacts are located inside this vacuum interrupter and are opened and closed. And in this section you can see the power contacts of the breaker, which, when the breaker is racked in and mounted inside the switchgear, they connect to the bus bar and the current enters through it and exits from here and is given to the output feeder. Here you can see the 33 kilovolt switchgear bus bar. As you can see, the bus bar is arranged in a triangular shape to take up less space in the bus bar compartment. For example, phase R or L1 goes up, phase S or L2 goes down, and phase T or L3 goes diagonally, forming a triangular shape. And this bus bar arrangement reduces the volume of the bus bar housing, and it's the bushing that connects the breaker to the bus bar. Inside this section you can see the connections. Yes, here the bus bar is connected to the bushing and from here it is connected to the breaker. Well, I hope you're now familiar with the 33 kV medium voltage switchgears. If you would like to learn more about these switchgears, you can visit our website at www.rojbin.com. We have medium voltage switchgear schematic reading training packages as well as training packages on their relays, and other trainings you can see on the site. Best wishes.